launch your Eclipse as usual, and then we'll create a project for today. Okay, and say OK here. Okay. Okay, so now let me just create a new project here. Sorry, let me just switch my workspace. It's not right. Okay, can we create a project for today? So let's go to File and New Java Projects. And let's type CSE114 Spring 17 Week 03 Lab number 2. Okay, and then we can say finish. Okay. I'm going to create different versions of the short circuit for us to experience. Okay, I'll start with exactly the lecture. You can play with it. So let's go to new and then class. Short circuits, SCIRCUIT. Short circuit, number 1. Okay, 1 here. And then make sure you select the main method here and finish. Like that. Okay, so why don't we try this? The example we did is about division, right? We want to somehow protect the division using 2 ways. Let's try conjunction first. Let's say if we simply do this, first of all, let's appreciate without the short circuit, what's going to happen. Let's say integer x is equal to, it's assigned to 0, and integer, you know what, let's make it more realistic. Let's do scanner. Scanner, let's say input is assigned to new scanner system.int. Okay, as usual. And we're going to read x and y from the user. Okay, it's completely off our control what user might type. So we can say integer x is assigned to input.nextInt. Okay, like that. And also integer y is assigned to input.nextInt. Yeah, we can make some prompt message if you like. So you can say system.out.println. Okay, we can say enter x. Okay, and then we can do the same for enter y. Okay, enter y. Okay, x and y. X might be 0, which would be dangerous. Okay, let's say we try to do very simple stuff. We just want to print out the result for y divided by x. Okay, this is all we want to do. If that y divided by x is larger than 2. Okay, so now let's try this. So we'll say if y divided by x is larger than 2. If that's the case, we want to say system.out.println. And we'll say y divided by x larger than 2. Otherwise, we can say the opposite, which will be less than or equal to 2, right? As we learned about negation, right? That'll be less than or equal to 2. Okay, so far so good? So let's now try different values to see how the program might crash. Let's say we go for, let's run the program here. So x, let's say it's 2. Y is 8. You would say y divided by x is larger than 2. That makes sense. Okay. Let's try something that will crash. If you say this, x is 0, y is 8. You can imagine this. We can predict when we go to this line here, it is going to evaluate 8 divided by 0. Mathematically, division by 0 is not defined. Programmatically, it will crash. Okay, let's try. Go back to the console, say enter. Okay, so this is what a crash is. It's simply called exception in Java. We'll talk about exception possibly in the last few weeks of the course, so you don't have to worry about it now. But whenever you get exception in your program, that's not good. Okay, so now it's simply saying that division by 0. Okay, that's something that's crash. Okay, let's make some comment here, and then we'll go to version 2 to see how the short circuit can help. The user may enter x being equal to 0, which will cause the program to crash. Crash, I mean terminates abnormally. Okay, that's what I mean. Okay, that's about it for version 1. Any question about version 1 here? So the point about version 1 is somehow we do some kind of protection for x. If x is equal to 0, then we have to somehow avoid that. Of course, you could have used some nested if statement to protect that, but that's not the way we're talking about here. We're showing to you how short circuit can be useful. Okay, now let's go to version 2. Okay. Okay, let's right click and say new class. That's a short circuit 2. Circuit 2. And then make sure you got the main method there. And say finish. Okay, so now let's copy some code from version 1. If you go back to version 1, you can copy basically everything from scanner line number 1 until the end of the else branch. Okay, go to edit and copy, and go to version 2. Okay, and then you can paste the code here inside the main method. Edit and paste. Okay, so now somehow you can see this out of the order, right? The indentation is not right. Control A, which will select everything on the editor. Control A. Control I will put indentation back. Okay, that's kind of a nice feature in Eclipse you can use. Okay, so now we somehow want to protect to say, well, if x equal to 0 is actually true, then we should really, so we know that the division will only make sense if x is not equal to 0 is the case, right? Otherwise, we got division by 0. So one way to do it is by saying x not equal to 0 and y divided by x larger than 2. What you will do is, when x is equal to 0, 0 not equal to 0 will be false. And we know that if one of the operands is already false, it does not matter what the other one is. It will be false anyway. So that's what short circuit is about. Right? So left to right. Let's try that. So I'll update the comments in a moment, but let's just do the code here. You can say x not equal to 0 and this. Okay, so here let's update the comments now. Okay. The comments I can say we use due to short circuit effects. If x not equal to 0 is false, then we will not evaluate y divided by x. Okay, that's kind of the comments, right? Which means if the left-hand side here is actually false, which means x is equal to 0, then we wouldn't go ahead to the right-hand side. Let's try this first, and then I'll modify the code a little bit and ask you if that will work or not. That's a little quiz. Let's try. Let's try this, and then let's say x is 0 and y is 8, which crashed on version 1. What about version 2? No, it was okay. Okay, let's be a little bit careful. So here, the message here is not really accurate, right? But I will leave it to you. Here is only for illustration, to say at least we didn't crash. Okay. Now let's try different possibilities here, shall we? Let's see. So this one works. Can we just copy this line here? Just this line, if statement here, just copy. Hit enter, and just put it into the same level here. I'm gonna put this into comments. We know that this works. You can put a comment here, working version. I'm gonna show you different versions here, and we're gonna study that together to see if that might work or not. Okay, version, let's see the first one I would like to show you, which we talk about in the class. All I'm gonna do is to swap the order of the two conditions. I'm gonna say, I'm gonna do the division first, and this. That's the variant I would like to create over here. Okay, only swap. Nothing has been changed except I swap the two operands of the conjunction operator. So now, who can explain to me if this will work or not? Give a try. Ryan? Yes. You will or you will not? You will not work. Okay. To start. Why? Why not?
Because it raised from left to right. So if you put 0, then
that's the first operator, the left one. Yeah. Exactly. So basically, for conjunction here or disjunction, you always evaluate the left hand side and then the right hand side. So before you can check if x is not equal to 0, you'll crash already. Right? Let's make sure we crash. And then I'll give you another more challenging thing to think about. Okay, 0, 8, crash. Okay, just by swapping the order, right? Let me explain that also in the comments. Okay, you can say that this version, which swaps the order of condition, will not work because evaluation is from left to right. So y when x is 2, y divided by x will crash first. Okay, something like that. Okay, I'll give you time to type. I want you to follow my comments. So again, I'll make the source available to you. So we know that this version here will not work. I'm going to give you another version, and I'm going to want you to think about why or why not it will work. So can we just put this one into comments? Okay, I'm going to type another thing. I'm going to say if, okay, let me just put the working version back, and I'll change it a little bit. X not equal to 0, and y divided by x larger than 2. Okay, we know that that one works. Now, I'm going to make the following change. I will change from conjunction to disjunction. Right? From conjunction to disjunction. So, literally it means x not equal to 0 or y divided by x larger than 2. So now, would this really protect the program from crashing? Think about it. Think about it. It's a challenging one. But hopefully after a weekend of study, hopefully that wouldn't be challenging anymore. But it won't be challenged every time. Think about it. Let me help you a little bit. What if x is 0? What will happen? I heard crash. Yeah. Why? Why crash? Yes. The disjunction is 4. Yeah, exactly. Very good. So let me just repeat what you said. Exactly. So now, if x is 0, 0 not equal to 0 is false. And we know that for disjunction, if you know one side is false, you cannot really conclude the overall result of the disjunction. You have to evaluate another one, right? Very good. Thank you. Okay, this one wouldn't work. Let me document that. Okay, let me document it. This version will not, this version, let me see. I missed the bracket here. Yes. This version, which changes conjunction to disjunction, will not work because when x is 0, x not equal to 0 evaluates to false. But disjunction will still require the right-hand side to be evaluated. Okay, something like that. I think I misspelled that. Disjunction still. Yeah. And don't panic if you cannot follow all the comments. Cannot type. I'm going to make this so it's visible to you anyway. Okay. Well, any question about version 1, version 2 here, and the various versions in version 2? Okay. That's really something you should think about very carefully. Because in the test or quiz, I might give you something similar or something maybe a little bit more difficult. Okay. But if you understand the table and the principle well, I'm sure you can think about it in the right direction. Okay, I want to do some another example quickly using disjunction. Okay, just to show you. Okay, very quickly. Okay, let's do this. Can we just go back to Package Explorer and then right-click, New, and then Class. Let's say short circuit number 3. Short circuit 3 with a main method. Okay, can we just still go back to version 1? Okay, that's easier. Go back to version 1, and then can we just make a copy again? Okay, everything within the main method. Version 1, not version 2, version 1. Go to Edit and copy. Go to version 3, which is empty here, and just paste. Okay, Control A, Control I. Okay. So now let's say I want to now protect this division here by using a different mechanism. I used to do it by using conjunction. Now I want to protect it using disjunction. Right? I want to say the following. X equals 0 or y divided by x larger than 2. You can see since I'm changing from conjunction to disjunction, so somehow this condition here are different, right? For the reason that if x happens to be 0, that is the occasion where I want to protect this division here, right? Now because I'm talking about this disjunction here, if this is true, that means I wouldn't bother to evaluate the second one anymore, because true or something would be true anyway. It doesn't matter what the second one is. So you should really think very carefully. So these two are really doing the same thing. But one is using conjunction, the other is using disjunction. And the condition used to protect will be different. Okay? That's kind of the thing you want to really think through. Okay, let's do that very quickly. So now let me just remove the comments here, okay? Because all the explanation will be very similar. Okay, so I'll just ignore that for now. You can look at the explanation for conjunction. You can derive the one for disjunction. So I can say x equals 0 or. Okay, this one will be the correct one. That's a working version. Working version. Okay, let's try 2 non-working version. Okay, let me just comment this out, and I can say if. Let me do the version 1 that doesn't work, which is to swap the order. I can say y divided by x larger than 2 or x equals 0. Right? So in this case, swapping the order wouldn't help, because in the case where x is really equal to 0, in that case you will do the division anyway, because from left to right. Right? It wouldn't work. For the same reason. I'll just make a very brief comment. Not working. Left to right. So you will get it. Okay. Let's try the final version that doesn't work. If you try the following over here, let's say we have if x equals 0 or y divided by x larger than 2. So this is the working version. So now let me just again only change from disjunction to conjunction. Okay? I would like somebody else to explain to me why this version wouldn't work. Anyone would like to try?
Because you change the versions to n,
So how about this? Try the value where x is equal to 0. What's going to happen if x is 0? Then 0 equals to 0 will be what? Oh no, you would crack. Okay, anyone else want to try? Ayam, would you like to try? If x is 0, what's going to happen?
It's gonna crash because first of all it satisfies the left hand side, but because the conjunction is n, it has to satisfy both sides.
Yeah.
But if x is equal to 0, then the second part is mathematically wrong.
Yeah, because only by knowing that the left hand side is true, it's not enough for you to conclude the conjunction will be true or false, right? So you gotta try the right hand side as well. That will crash. Okay, very good. Yeah. So that's something I would like you to practice because most likely I will ask you to explain in the quiz or in the test. Something similar. Okay. So this is kind of the logical way of thinking I would like you to train you. That's very important. Okay, very good. So this one wouldn't work. So let me just comment the working version back. Okay, this one will work. Okay, any question about the short circuit? Any more? Okay. As I said, please study this very carefully because once you go to 214, we actually will still see that the short circuit quite often. Okay, no question. I'm gonna talk about loops quickly. I just want to do a few examples to give you some intuition. Okay, let me stop this recording.